In the last two episodes, we talk about data and code and how code is data and data is code. And I think there is one more word we can debunk here, which is homoiconic. So I think this is exactly what we were talking about over the last two episodes. Is that right?
That's right. Yeah, homoiconic is a wonderfully long and fancy word, which just means you're sort of using the same data structures for your code that you are for your data. So the homo or sort of same part of that just means that it's the same representation of code as there is for data. And there's really not more than that. It tends to be one of those words that people use to scare the children, but it really is a very simple idea. And it's a lovely idea, too, because it means the language gets that much simpler and it enables macros and things like that.
With this out of the way, maybe let's talk about immutability. So in Clojure, we have immutable data structures, but we can still switch them with atoms. So how does that all come together?
Yeah, atoms are kind of I think a lot of people who don't know about functional programming, one of the things almost everyone knows about functional programming is that we don't like mutable state, right? Mutable state is all about side effects. We don't like side effects. We don't like mutable state. And atoms, strangely enough, are one of Clojure's and pretty much the only way in ClojureScript that you can represent mutable state. And so atoms are a feature of Clojure and ClojureScript specifically designed to represent mutable state, which seems like a puzzle because this is a very functional programming language. And why would you have a special construct, a special feature to represent mutable state, which is supposed to be the thing that we don't have in functional programming?
Right.
It's not a problem with Clojure. It's a problem with kind of our conception of what functional programming is all about. So I have some questions for you.
Okay.
If you're working on a project for some customer, what are you actually doing for the customer? Like, what are the things that the customer cares about? You're working on an accounting system or some web application or something. Does your customer really care about the patterns of bits inside of the CPU?
Well, probably he doesn't. I think what he cares about is that it's, if we talk about, for example, accounting system or any other system, that it's correctly working, right?
And how does the customer know that the system is working?
Well, he can, after it's done, he can take a look and sort of do the user acceptance tests.
Right. And so your customer might be looking at the contents of a database or some report you've generated, maybe some PDF file. Maybe he's looking at some other service where you were supposed to hit the service and do something against the service API, right?
Correct.
Okay. You know what all of those things have in common? They're all side effects. Right. They're all things we are doing to the world. We're writing PDF files or other kinds of files. We're changing databases. We're hitting other services. Maybe in a ClojureScript application, maybe you're just doing something as simple as changing the DOM so that the colors and letters and whatnot on the screen change. But they're all side effects. The people who pay us to do our work, all they care about are the side effects. And so if you sort of think about functional programming as not wanting to do side effects, it seems like functional programming can't actually do anything. It can't do the things that we actually want the functional, our programs, whatever kind of programs do. And the answer to it's not really a mystery. The answer is that functional programming is all about how do you arrive at the results. And the answer that functional programming has is that you arrive at the results by, using immutable data and calculations and pure functions, and that you do not arrive at the results by using side effects. But once you have the results, you must do some sort of side effect. You either need to change the state of your program, right? Like think about a hit counter in an old-fashioned website, right? Congratulations, you're the 500th visitor.
Right.
Or you're changing the database, or you are creating a file or something like that. So sort of the answer to the mystery of having atoms and in a functional language, having a way to represent mutable state in a functional language, is that the changes to the mutable state are the end result. They're the isolated end result of your computing, but you do all the rest of the computing without changing state, without having side effects and everything. And then you isolate the mutable state off in some other thing, which in ClojureScript and Clojure are atoms. Clojure actually, I should back up and say the server side of Clojure actually has several ways to represent mutable state. But in ClojureScript, it's a little bit more restricted given the
Right.
sort of single-threaded callback model of ClojureScript. So the one that you have in ClojureScript is an atom. But
Correct.
it's there to be the end result. I have some state that I want to represent that's mutable in my application, but it's very isolated. It's off the one side. And I don't really use that state, like changing that state to arrive at my result. It's used to store the result. And that's what an atom is for.
So if I could just add something. So normally when we were working with ClojureScript, we would work on immutable data structures.
Right.
And only then at the very end, as you said, it's isolated. Only at the very end, we would just do some side effect. So it's not like in every other like programming language, let's say Python, JavaScript, where you would just be mutating things all over the place.
Right.
And you really don't care if it's at the middle or at the start or at the end. So in Clojure, we just try to push all of this to the boundaries of the interaction.
And isolate it. And the reason you do that is because that mutable state is the hardest thing to think about in your program. So what you do when there's something difficult in a program, right? Well, I think all programmers do this. When you have something hard and messy and ugly in a program, your first instinct is to isolate it, to get it away from the rest of my code so that it doesn't infect the rest of my code. And the sort of the revelation of functional programming is that mutable state, whatever form it takes, a file on the file system, or just maybe a counter or something inside my program, is one of those things that's nasty and difficult to deal with. So you isolate it so it doesn't infect the rest of your code.
So you mentioned that in ClojureScript, we have only atoms.
Right.
And yeah, so this is mainly because JavaScript is single-threaded. I know that there are some, the WebKit team is working on multi-threaded JavaScript, but I don't think this is anywhere close.
Right.
So what are the other mutable data structures?
One of the other ones is that you find in Clojure, but not ClojureScript, is agents. And an agent is that idea that I have you find them similar things in lots of languages. I have a queue, and that queue represents a kind of a list of things that I need to do. And then there is something listening on that queue, and it's executing those things in order. And so an agent in a Clojure application, say running under the Java VM, is the way that, or at least one of the ways that you affect the outside world. If I want to affect the outside world and I want to do it such that the different things that I'm doing aren't overlapping, say I'm writing to a single file. Well, I might have an agent that sits there and writes to the file, and it's listening on this queue, and it's discovering things that it needs to do, and then it takes one at a time off of the queue and does them. So that sounds like a lot of like queue-based systems. The interesting thing about agents in Clojure is the things that you put on the queue are functions. So essentially you're throwing functions at your agent, and it takes each function off of the queue and executes it. And so the function that it takes off the queue tells it what to do. In other words, essentially delete the file, update the database, whatever it is. So that's an agent. In order to understand refs, you really have to understand atoms, I think, because an atom is kind of like a simple version of a ref. So why don't we talk about atoms first, and then we'll come wrap back around and talk about refs. So
Okay.
as we said, atoms are the thing that you find in both Clojure and ClojureScript. It's the only sort of mutable state thing that you have in ClojureScript. And really, an atom is just a container for a mutable value, which sounds remarkably like a variable.
Mm-hmm.
The difference between an atom and a variable is the way you change an atom. The typical way that you change an atom is that you throw a function at the atom, and the atom will take the function, and it should be a function of the value of the atom. And so the atom, when you throw a function at the atom will take the function, it will take the old value that's stored in the atom and
Mm-hmm.
execute the function, evaluate the function with that as the parameter, and whatever comes out of the function, the result of the function, becomes the new value for the atom.
Mm-hmm.
And that's pretty much it. So an atom is a container for mutable state, so it always has a value. That value might be nil, but it always has a value. And the way you update atoms is you send functions at it, and the function produces the new value from the old value. So if you really did have a counter, it would just be you'd send the increment function at the atom, and the atom would, if it starts at 0, it would increment 0, get 1, and that becomes the new value of the atom, and it would just march from one value to the next. And that's pretty much atoms. We tend to think, when we introduce atoms, we tend to think of them as, or at least explain them as having integers or numbers or something like that. But in principle, you can have any value, some huge hash. Your entire data, your entire application state can be in an atom.
Right. And then when we will be working inside our application, we will be, for example, updating this nested structure somewhere inside there. And then we can mutate all of the states. So in the UI, it might be, open model or open pop-up. And then we will just have a value, for example, for true or false, where we'll be showing this or not.
Right. Yes. Yeah. So atoms are they are a systematic, they're a container for a mutable state with a systematic way to march from an from the old value to the new value to the newer value, and so on. And it's just a simple way of isolating. So really what an atom is kind of an adapter. On the one hand, you have this lovely functional world where all the data structures are immutable and everything happens with these pure functions and life is good. But at a certain point, you get to the point where maybe I have to change some state in my application. That state is mutable state. So you work out a function that you send at the atom that changes the state of the atom. So it's sort of an adapter between the functional world where everything is immutable and the nasty sort of mutable world of real life and the outside world, if you will.
Okay. So how does Atom compare to Agent?
Number one for our discussion is that agents do not exist in JavaScript. So,
That's
let's
correct.
keep reminding everyone of that. The difference is that an agent has a queue and it's pulling things off of the queue and it's changing the value of the agent by, executing the function. So agents have a value. They're also sort of containers for mutable state. But since everything is sequenced in order, you can also use agents to delete files, do things outside of your application, update the database, and that kind of thing. Mm-hmm. Atoms are just these mutable boxes. So atoms are simpler than agents in that they're just a box for a mutable state, and you send the function to it, and that function goes from the old value to the new value of the atom.
Would it make sense to, for example, so what's the advantage of having, for example, 2 atoms versus let's say, one agent?
An agent, and again, the agents only exist on sort of server-side Java, but agents serialize the work that comes to them. So with an agent, you will never have, if I say operation A and operation B on an agent, maybe delete this file and create a new file, or, maybe more to the point, take this money out of this account and put the same money in a second account. With an agent, you're pretty much guaranteed those things will happen in order and not at the same time. With two atoms, at least, JavaScript is sort of different because it's got the single threaded thing going on. But in principle, with an atom, if you have two atoms, in principle, the updates could happen at the same time, or, it's sort of arbitrary if they're happening on different threads. Again, that's not much of a problem in the JavaScript world. It's a much more serious problem on the server side world.
Right. So
go ahead.
We would use agents when we want to fight sort of with race conditions. Would that make sense?
Well, it's when you have a single flow of work and you are trying to serialize that flow so that it all happens in a definite order. So that's one version of race condition. Again, on the server side of atoms, there's also a race condition that can happen with atoms, which is, what if two different threads come in and try and update the same atom at the same time? Like, what if I'm just counting something and the count is currently 4, and I get at pretty much exactly the same time 2 updates coming in, both of which are going to increment this counter, so I should end up with 6. The thing you're always afraid of in those situations, just in terms of multi-threaded code, is that I'm going to miss one of those updates. Like, one of the updates is going to come in C4, increment it to 5, while at exactly the same time the other update comes in, C4 increments it to 5, and then the final value ends up at 5 instead of 6, is always the fear in a real multi-threaded environment. What atoms do to avoid that, again, on the server side, but I think it's interesting to talk about, is that there's actually sort of this multi-step process when an atom gets updated, is that the mechanism behind an atom, when a function comes in, so I need to update the atom, it will look at the value of the atom, and it will use that old value to compute a new value with the function, and then you can look at it this way. Essentially, right before it puts that new value in, it checks to make sure that the value was still the old value I started with. If it's still the old value I started with, it's okay to put the new value in. But if that value has changed out from underneath me, which means that someone else updated the atom while I was in the middle of computing the function, it does something very simple. It recomputes the function based on the new old value. And so that way, atoms, even in a multi-threaded environment, are guaranteed to march forward in a sensible way. But it also means that you should not have side effects in the update functions of the atom, because if you have side effects in those functions and the function gets run 3 or 4 times, if there's a bad bit of contention going on, then maybe bad things will happen with your side effects.
So we have atoms, and then we have agents, which are the queues. And right. So what are the refs?
So refs are kind of like, if you think of an atom as sort of kind of like a database, right? It's like a trivial little database. And,
right. Yeah.
And, because I can store things in it, and then I can do these transactions on my little one value database. Refs give you transactions, what would be the equivalent of multi-table transactions in a SQL database. So a ref, you can have a number of refs and you can update them in a safe way all together. So effectively, you have a transaction on your ref, so that, and this is a way where if I have 2 independent values, I can essentially put them in 2 refs, and the refs, when they're alone, look just like atoms. But the difference is that I can sort of say, okay, now I'm going to update these 3 refs, and I'm going to do this to this one, that to that one, and this to this other one, and that these sets of changes to all 3 of these refs, they all have to go together. And then it more or less uses the same rules as atoms about resolving the contention.
Yeah, and is there order also guaranteed in refs? So if I do 3 updates?
So within the software transaction, the order is guaranteed. But if you have two updates to either atoms or refs that are coming in more or less at the same time, you will not be sure which one will go first and which one will go second. But one will definitely in its entirety go first, and then the second one in its entirety will go second, if that makes sense.
Okay, so if I want to have always guarantee of my updates, I would use agents. If
Right.
I want to do couple of changes, maybe I don't care about too much about the order, I would use refs.
Yeah.
And for the single values or single, I don't know, let's say hash maps, whatever, I would use atoms.
Right. But here's the thing that I think we don't talk about enough in sort of when we, people like me talk about closure, is if you look at real world closure applications and real world, closure libraries and things like that, even on the server side, what you find is you will find a few instances of agents, very, very few instances of refs, and the enormous majority is atoms. So if you're a new closure programmer and you find yourself, well, if you find yourself in ClojureScript, atoms are what you have. If you find yourself doing server-side closure, atoms are probably what you want anyway. It turns out that this is a case where simple is actually better. That most experienced closure programmers, when they're doing this sort of thing, they will just reach for atoms, and chances are atoms are what you need.
Putting all of this together, what we discussed. So we have those immutable data structures.
Right.
And whenever we want to swap something, and I'm using the name of the function from Clojure, how we would work with atoms, whenever we want to swap something, we would use for that atoms in ClojureScript. On Clojure side, we will use atom refs and agents, and most probably you will still use atoms.
Right.
So
Right.
actually, for me, whenever I thought about the atoms on ClojureScript side, was some kind of like a border control,
Yes. It's the barrier between the easy to think about functional world where all your data structures are immutable and things don't happen just out of the blue because one of your data structures changed out from underneath you and all of that terrible stuff that goes on. So it's a barrier between that lovely world of functional programming and the sort of nasty, messy outside world where things change and there's side effects and there's all kinds of crazy stuff. And you need that barrier to keep all the crazy stuff from infecting your program. But you can look at it either as a barrier, like, a border or a checkpoint or whatever it is. It's two things. It keeps things separated, but it also lets the traffic in and out, right? It also in a controlled kind of way. It's funny, the way I think about it is whenever they call it, cells are covered with membranes, but then the membranes are not a complete barrier. They let certain molecules in, and I think of it that way, right? Like the membrane around a cell is designed to keep the chaos of the outside world from messing with the insides of the cell. But you've got to get food and water in and out, and all that kind of stuff. So it's a controlled barrier. It lets some things in, lets some things out, but mostly it's separating the lovely mechanism from inside the cell, or maybe your functional program, from the messy outside world.
So is there anything else we should talk about when you talk about state in Clojure? Because it looks very simple, actually.
It really is. I think that the fundamental surprise of functional programming is that you can do 98% of the business logic of your application without mutating anything at all. I think that if there is sort of a message that people who don't do functional programming, who are thinking about it and wondering, is there really an advantage to this style of programming? It is that you are working too hard to write your business logic. That if you compute with side effects, you are making life harder on yourself. What you should do is you should do the computation, the computing, and then at the very end, generate or inflict whatever side effect you need to inflict on the world based on doing this computation without any side effects. I think certainly it surprised me when I started programming in a functional style, is that you don't need the side effects. And in fact, life is a lot easier if you compute without side effects. Eventually, you need to delete the file, update the database, or whatever, but you can as you put it, isolate that and keep it away from the guts of your program.
So yeah, I think this is actually a very good summary to finish this episode. So as you heard, there is not much about the state in Clojure and ClojureScript, and it looks pretty simple.
It actually, I at the risk of repeating myself, it really does make life simpler if you get rid of the side effects and isolate them out at the edges of your program.
All right. So thanks so much for your time, Russ. And once again, if you're interested in getting the book, please use the link from the show notes. This way, the author will get the better part of the deal.
All right. Thank you. It's been great talking to you.
All right. Cheers.
All right.
If you find this podcast valuable, there are many ways you can support it. You can review it on iTunes or any other platform you're listening to. You can share it on social media with your friends. You can blog about it, discuss it on your own podcast, and you can support it directly by buying my video courses and learning ClojureScript and Clojure at my website, jacekschae.com. That's JACKSCHAE.com. Thank you for your support of this show.